All right, welcome back, everybody. We're going to do a few practice problems from worksheet 8.3, and then your homework is going to be to finish the problems that we don't get to. We're going to do problems 1, 2, and 3, and your homework is going to be to do problems 4 through 11 this week on the ideal gas law worksheet 8.3. Okay? All right, so we're going to do problem 1 together. What volume, so that's what I'm looking for, will 20 grams, there's a variable, of argon occupy at STP? Most of you, or a lot of you, may be confused and say, well, I'm not given very many variables to solve. The equation that I'm going to be using most of this worksheet is PV equals nRT. So I would probably write that down somewhere, and hopefully, again, we're comfortable or getting comfortable with that equation. Okay, this is going to be the equation we're typically going to use. And I'm looking, in this case, for volume. So I see grams, that's not a variable, and I see STP. Well, that is a variable. Remember, STP is a temperature and a pressure. So my temperature is 273 kelvins, my pressure is 1 atm. But what about grams? Well, remember, and the hint says, can I use grams to get moles? And yes. So I take 20 grams and I convert to moles using my molar mass. Then my pressure and temperature are 273 Kelvin for temperature and pressure 1 atm. I'm looking for V, and the gas law that I use is PV equals nRT. Okay. Now I'm solving for V. So I'm going to take P and move it to the bottom. So it looks like V equals nRT over P. And I plug all my variables in. All my units end up canceling except my volume of 11.2 liters. Okay, my volume is going to be in liters. So I'm using PV equal nRT, solving for V. My variables aren't directly given to me, but hopefully it makes sense where I got them from. All right, number 2. How many moles of gas would be present in a how many moles of gas would be present in a gas trapped within a 100 milliliter vessel at 25 degrees Celsius and a pressure of 253.25 kilopascals? So I like to underline the variables. Now it looks like I'm looking for moles, so that's going to be my unknown. 100 milliliters is a volume. 25 degrees Celsius is a temperature, and 253.25 kilopascals is a pressure. All right, so I'm looking for moles. My volume isn't in liters, so I do need to convert that. You can divide by 1,000 or move the decimal 3 places to the left. And my temperature isn't in Kelvin, so I need to add 273. My pressure is 253.25 kilopascals, and the R that I'm going to use in this case is 8.31 because my pressure is in kilopascals. If my pressure was in ATMs, I would use 0.08206. Okay? All right, so the R that I use is 8.31. I'm looking for N, so I have PV over RT equals N. I plug my variables in. Everything ends up canceling except moles, and here's my answer. 0.0102 or 1.02 times 10 to the negative second moles. Question number 2. Question number 3. If the number of moles of a gas is doubled at the same temperature and pressure, will the volume increase or decrease? Not really a question with any variables. So this is more of just understanding, okay? I'm not using PV equals nRT necessarily in the sense that I typically have been. I'm just answering the question based on Avogadro's law. If the number of moles of gas are doubled, so if I double the amount of gas in a balloon, what happens to the volume? Increases, and that is Avogadro's law. So hopefully that gave you a basic introduction to our worksheet. Remember, the gas laws that we're using are PV equals nRT and, okay, molar mass equals MRT, that's RT, over PV. So these are the two equations we're going to use this worksheet, and hopefully, again, it makes sense once you start doing these problems. The more you do, the better you'll be. Okay? So our goal was to understand the kinetic molecular theory and apply that to the ideal gas law. So that's our goal, and your homework is to finish worksheet 8.3. We've done numbers 1 through 3. Your job is to do numbers 4 through 11. Please send me those answers when you're done. Thanks. Look forward to seeing you in our class meetings.